was going to say, this title is enthralling.
I can't see very well. That's okay, I'll see. Plus, I think some of these desks are small. Now maybe it's just. Okay. Thanks, Nicole.
Okay, right now I'm going to teach you about the universe and everything in it. The possibilities of endless stars, planets, moons, and multiverses more than I will talk about, because space goes on further than light itself and longer than we could ever imagine. A few astronomers that gave us the basics of discoveries on the universe starts with Nicholas Copernicus. He believed that the sun was the center of our universe. And next is Galileo Galilei. He discovered that the earth revolved around the sun. And Johannes Kepler, he developed that the planets moved in ellipses or ovals and not circles. Next, I'm going to be talking about NASA. Now, NASA was created on July 29th, 1958, because of the Soviet Union's launch of Sputnik. The first major mission that we took in was Project Mercury, and John Glenn was the major astronaut in that mission. We wanted to test the orbit of the manned spacecraft around Earth and investigate man's ability to function in Earth, because we didn't really know what would happen. On February 20th, 1962, Glenn's spacecraft called Friendship took 4 hours and 56 minutes to circle around the globe 3 times. Apollo 11 was the first to land on the moon ever. Neil Armstrong took the first steps, and it was a long journey to get there, because in Apollo 1 it didn't even get off the launch pad before it blew up, so that's a big deal. Next I'm going to be talking about the Earth. The Earth was the only planet not named after a Greek god or goddess. It was named over 1,000 years ago, and it's our 5th largest planet. It consists of 4 layers: the inner core, which is 759 miles thick. It consists of a nickel and iron metals, and it gets as high as 9,800 degrees. After that is the outer core, and it consists of the same thing, but it's twice as thick as the inner core. After that, we have the mantle, which is molten rock, and then our crust. Earth's atmosphere protects us from radiation from the solar system, and because of the balance of water, land, and the combination of gases is why we can have Earth on this planet. Now, Earth's moon contributes to our existence as well, because it moderates the wobble of the axis of Earth. It looks pretty close from Earth, but it's more than 200,000 miles away, and it's getting further by 1 inch every year. Other than the phases of the moon, we have a solar eclipse, which is the moon moving between the Earth and sun, causing darkness even in the middle of the day. And a lunar eclipse, which is the Earth blocking the sun. Light that lights up the moon, causing us to see the moon as red. Now, facing the sun, the moon gets up to 260 degrees, but in total darkness it gets to about negative 280. And compared to the Earth's atmosphere, the moon's atmosphere is very frail and thin. Other moons that I found interesting and I want to talk about is the Ganymede. It's the largest moon in our solar system. It's larger than Mercury, Pluto, and 3/4 of Mars combined altogether. It belongs to Pluto, and it was discovered by Galileo in 1610. It was the first moon discovered orbiting a planet other than Earth, and it has an icy surface. After that is Deimos, and it's the smallest moon. Its surface consists of small, lumpy, and heavy cratered objects. It's one of Mars's 2 only moons, and it circles Mars every 30 hours. It's very similar to an asteroid, and it was discovered in 1877. After that, I just picked one that was really interesting to me, so I picked Lo, which is the most volcanic active body in our solar system. It's Jupiter's 3rd largest moon. It looks like a giant pizza, honestly. It has a whole bunch of yellow and red spots because of the volcanoes. It's only a little larger than our moon, and it faces Jupiter the same direction, so it doesn't spin at all. And it was also discovered by Galileo in 1610. Next, I'm going to talk about the sun. The sun is a part of our solar arm, spiral arm. It's defined as a cluster of strong star formations. It has an axial tilt of 7.25 degrees, and because the moon is created of only gases, it spins at different rates all around it. We predict that it's halfway through its lifetime, and when it does burn out, we expect it to swallow Mercury, Venus, and maybe even Earth. The layers of the sun are more complex. It starts with the core, which is 27 million degrees. Then there's the radioactive zone, convective zone, photosphere, chromosphere, and lastly the corona, which is 10,000 degrees, which is still really hot. Next I have the white dwarf. And this is what we predict the sun to turn into when it burns out. It's defined as the core of any star that expands rapidly and dies out. The temperature is as high as 200,000 degrees, which is still really hot, but not as hot as 27 million. We predict that there's a diamond-like substance in the core because of the carbon and oxygen levels under the 30-mile crust. Now, a solar system is defined as a star and all the objects that travel around it. The solar system moves at about 450,000 miles per hour, and it takes about 230 million years to complete an orbit around the Milky Way, which basically means we're in the same spot we are as we were when the dinosaurs roamed the Earth, which is really cool. There are 149 known moons, 5 dwarf planets, and 8 planets. First is Mercury, then Venus, Earth, and Mars. They're solid rocky planets, and that's why they can orbit so close to the sun. Next is Jupiter, and without Jupiter, we wouldn't be alive because the gravitational pull on Jupiter is so strong that it pulls asteroids towards it, so they wouldn't hit Earth. After that is Saturn, and it's the only planet that we can see the rings from Earth. After that is Uranus, and it was the first planet discovered with a telescope. And after that is Neptune, which is the farthest planet we consider a planet. I'm going to talk about the multiverse, and it's basically all possible outcomes for reality. Level 1 is infinite galaxies, Earth, and copies of yourself. Level 2 is infinite Big Bangs, which takes the idea of level 1 and creates different outcomes. Level 3 is infinite dimensions. For example, if you were to suddenly think to ride your bike in a different dimension and universe, you'd opt to walk, and both exist. Level 4 is infinite mathematical structures, which just means any universe that is mathematically possible, like multiplication, addition of like atoms, could possibly exist, and I personally like the infinite dimensions because it's cool to think about. And lastly, I'm going to talk about the Big Bang Theory. It's based on how the universe started. If we would have seen the universe any second after the Big Bang, we'd see billions of degrees of neutrons, protons, electrons that would turn into our transparent universe. And Albert Einstein really liked the idea of a Big Bang, and he had a lot of ideas to back up the Big Bang Theory. And these are my works cited. of documentaries that I watched recently that, we actually got a whole bunch of astronomers to create an idea of what Mars would look like and our advances to Mars, and it's a good documentary.